Hi, it's Bentley's mom. We're going to do the homework, chapter 12, lesson 3 for the box and whiskers plot. And we're going to do guided 1 through 3, independent 1, and hot 8. And in general, in your packets, if you do the guided, a couple from independent and 1 from hot, you're in a really good spot. So, okay, the first thing I'm going to do is take the data and put it in order. Okay, and then I'm going to look at my data. It goes from 1 to 15. So I'm going to draw a number line. And I'm just going to go by ones from 1 to 15. If it was like 1 to 100, I'd go by tens. 1 to 50, you'd go by fives. So decide what your interval is. Just make sure it's the same. If you go by twos the entire time. If you go by fives the entire time. Okay, so the first thing I'm going to do, anytime we're doing box and whiskers, is you find the median, you cut the data in half, and then you find the middle again of the lower side, and then you find the middle again of the upper side. So basically you're finding the middle again, and the middle again. And that divides the data perfectly into quartiles, which is 25%, 25%, 25%, 25%. Okay, so here we go. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It's a tie. Okay, so the number between 5 and 7, the median is going to be 6. So I'll put the median down here. Okay, and again, if these were two numbers that you couldn't tell who the middle was, you add them up and divide by 2. 5 plus 7 is 12. 12 divided by 2 gives you 6. So the median is actually right here. It's not 5 or 7. It's 6 in between. So because it's not one of these numbers, we use these numbers to find the middle of from here to here. So 1, 2, 3, 1, 2, 3, and now our quartile 1 is at 4. So Q1 is 4. Okay, and then we're going to find quartile 3. So we're going to do the same over here. 1, 2, 3, 1, 2, 3, and there's Q3. Okay, which is 9. So what this did is this is the first 25% of data, the second, the third, and then the last. Okay, so let's plot the median first. So it's going to be 6. I go to 6. I make a dot above the number line, not on the number line. Go above it. Make room for yourself to draw the actual box and whiskers. And then I like to do the dots all the same level. So now we're going to do Q1, which is 4. It's right here. And we're going to do Q3, which is 9, which is right here. Okay, now between Q1 and Q3, that's the end. That's the two sides of your box or your rectangle. So I'm going to draw the box, and those are my two ends. Okay, and then the median, just draw a big fat line. So that's your median point through that. Okay, and then we're going to do the whiskers. So our minimum point here is 1. So I'm going to draw a dot on 1. And our maximum point here is 15. So I'm going to draw all the way to there and then draw the whiskers out. So it looks like this. Okay, so here's our minimum point, quartile 1. That's 25% of the data. Here's the median. So from here to here is the lower 50% of your data. And from the median to the end, that's the upper 50%. And then this just breaks it into 25% and 25%. Okay, so that is the box and whiskers. Now it says, what percent of the earthquakes were between 4 and 9 kilometers deep? So between 4 and 9, that's quartile 1 and quartile 3. That's your box. So what your box represents is the middle 50% of your data. Not the first 25, not the upper 25. The middle 50% of your data is between 4 and 9. So B, it says what percent? So it would be the middle 50% of the data. And then C, it says write a sentence explaining what the length of the box plot means. So the length of the box, Bentley, do you know the answer to that? What does that represent? It represents what percent of the data?
50%.
Yep, and the middle 50% of the data. Now the entire plot from this whisker to this whisker, and minimum and maximum, would represent 100% of the data. But the actual box is the middle 50% of the data. Okay, that was number 1. Now let's do number 2. Okay, number 2 says, find the median and the measure of variability for the box plot shown, then describe the data. So they give you the data. They have a drawing for you. So I'm just going to draw it here. It looks like, here's a number line. And we'll do 21 to 23. So I'll do 21, 23, 25, 27, 29, 31, 33, 35, 37, 39, 41, 43. So they drew this for you. It looks like this one's about 22, then the next one's at 25, and then the next one's at 27, and that's where your median is because of that line. Then the next one's at 33, and then we have, looks like around 40, right around here. Okay, so the middle one is your median, okay, and then we're going to draw around Q1 and Q3, that's our box. Okay, and then there's the whisker, and there's the other whisker. So sorry, my drawing's not the best, but they drew this for you. So it says find the median, and then we're going to find the measures of variability. So we're going to find Q1, Q2, the range, the interquartile range. Okay, so our median, Bentley, what's the median here? Is 27. Good. Okay, what's quartile 1?
25.
So quartile 1, yep, is right here. It's 25. What's quartile 3?
33.
Quartile 3 is this one right here. Yep, it's 33. Okay, so basically what you're doing is you're just learning how to read the data from this kind of graph. There's bar graphs, there's line plots, there's all different types of graphs. This is just called a box and whisker. So you're learning that you can look at this really quickly and it cuts your data into 25%, 25%, which are called quartiles. Okay, so quickly you should be able to see the median's 27, Q1 is 25, and Q3 is 33. And that's just being able to read this. Okay, then let's see. Let's find the range. So the range is we're going to take our biggest piece of data, which is, looks like 40, and then we're going to subtract out 22. Okay, and we get 18. That's the range of our data. Now the interquartile range, do you remember how to do that, Bentley?
You just times by point.
No. The interquartile range, you take Q3
quartiles.
and you subtract Q1.
Yeah.
So what's Q3?
33.
33 minus 25 is 8. Yep. So between these two, or your middle 50% of the data, it spans between 8. Okay? And then describe the data. You could just say, the range, the total range is 18, interquartile range is 8. You can just kind of write this in words if you want. The median is 27. So basically they're looking for this information. Okay, number 3. All right, number 3 says, how is the information you can learn from a box plot different from what you can learn from the same set of data shown in a line plot? So a line plot, in general, it's just asking what the difference is. I would say something like a line plot shows more frequency, the frequency of the data, shows the frequency of the data, where the box plot, or box and whiskers plot, shows what? Shows the median
and the quartiles.
And the quartiles, good. Yep.
And the range.
Yeah. And range. And I mean, you can also look at a line plot and see the range too. So something that's the same as they both show the range. But definitely, if you're looking for a type of graph that will show the median and cut your data into quartiles, then you want to use a box plot. If you're looking to show frequency of certain items, which is kind of like a bar graph, you would use a line plot. So it just kind of depends on what kind of graph you're looking for. All right, let's do, okay, now that was guided. Let's do independent. Okay, so independent, number 1, it says draw a box plot for each set of data. Okay, so for number 1, we're just going to draw the plot. And, you know, if you can draw a plot from the data and understand Q1, Q3, the median, and the minimum and maximum, you're in a great place. Okay, so let's do, the first thing we have to do is take that data and do what with it, Bentley? Put it in order from least to greatest. So we have 35, 55, 61, 65, 74, 88, 92, 96, 97, 99, and 100. Okay, so I'm going to start, so we're going to draw, so I'm going to start, here's my graph. So I'm going to start at 35. I'm going to go by 5s from 35 to 100. So 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105. So you can just do this by hand. Doesn't have to be perfect. If you use a ruler and do or on graph paper, that would help. But as long as it's close and you try to space your tick marks, you know, the same distance apart, you're fine. Okay, so the first thing we're going to do is find the median. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It looks like the median is at 88. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the median is 88. Okay, so I'm going to plot that. It's about right here. Okay, I'm going to do a big dot. Okay, now I'm going to find quartile 1. Okay, so I'm going to find the middle of this, of the lower half. So 1, 2, 1, 2. It's going to be 61. Okay, so I'm going to plot 61. Okay, then I'm going to do Q3. Okay, so 1, 2, 1, 2. So quartile 3 is at 97. Okay, and then I'm going to go to 97. And it's about right here. Now, the Q1 and Q3 are the outside of your box. So you're going to draw your box around those. Okay, and then your median, do you remember what I would do with the median?
Make
a nice big line here. So this is your median. That's Q1, and this is Q3. Okay, now we're going to do our whiskers. So our whiskers are our minimum and maximum, or our lower and upper extremes. So our minimum point would be what, Bentley?
Minimum point would be 35.
35, and what's our maximum?
100.
Good. Okay, so we make a dot at 35, and we make a dot at 100. Okay, then you draw the whiskers out. Now you can tell the second half of the data, isn't it way more concentrated? All the numbers are way closer together.
But it's still
where from
25%.
here to here, the first 50% is spread out. You can see that by, you know, how short the whiskers are. Okay, and that's all it asks us to do is just to draw that. Okay, so again on a box and whiskers, you do median, Q1, Q3, and then the two whiskers, which are the minimum and maximum. Okay, and then let's go to the hot problem. Number 8. And again, the problems I'm doing, if you understand what I'm doing, you're in a great place. Okay, so number 8 says, what can you conclude from a box plot where the length of the left box and whiskers is the same as the length of the right box and whisker? Okay, so what do you think about that, Bentley? Here's a box. Let's say your whiskers are the same length.
Yeah.
What does that mean if they're the same length?
The mean is also the...
Well, here's the median. What it means is, isn't this data equally spaced from this one? They're like, so basically, if the whiskers are the same length, that means this lower 25% of the data is concentrated in the same way that the upper 25% of the data is. So you could say something like, if whiskers are the same length, it basically means then the lower 25% of the data, you could say, is dispersed or is distributed the same as the upper 25% of the data. Okay, and then if the box, if the median was right in the middle, same thing. If the box is equally cut in half, then the middle 50% of the data, is dispersed. Now, if it's really concentrated, like on the lower half, what would this do? Wouldn't that be way shorter?
Mm-hmm.
So if it looked like that, that means the numbers are concentrated. They're close to each other. And here, they're more spread out. But when the whiskers are the same, and they're equal on both sides, it just means the concentration's about the same. Okay? And that's it. Have a great day. Bye.
Bye.